right, happy Friday, everybody. You guys know it's supposed to be nice and toasty this weekend, so hopefully you can enjoy some more time outside. No, I'm looking forward to it.
Wait, are you being for right now?
Yes.
I just don't know when you're about to make a joke.
I know.
Or you're being serious.
That's more than half the fun of doing these. The jokes today are actually kind of hard to disguise. What is orange and sounds like a parrot?
A carrot.
Nice! Well done! That was quick.
What? I was gonna guess that, but I just spoke them.
Okay.
I like hard carrot in my head, but I was like,
A sandwich walks into a bar, and the bartender says, "We don't serve food here."
Oh.
Eh?
Oh.
Because he's
like
food.
That's right.
Yeah.
This was a good one.
Yeah, not bad. Okay, so we're going to take a quick look at worksheet 1, and that's about all we're going to do today. So I know for sure we want to go over number 5 and 6. Is there anything else from page 1 that you guys would like to look at? Fair enough. Yeah, number 3 and 4 should be pretty straightforward. Number 1, acceleration, is pointed to the center of the circle there. So, yeah, wherever it is, if it's on the side or the top or on the right side there, the acceleration is always pointed towards the center of the circle it's going around. Centripetal acceleration, basic equation, v squared over r, you should get 4.84. Centripetal force is just that 4.84 times mass, because force is mass times acceleration. And that was 484 then. For number 5, it says make a quantitative force diagram for the go-kart. So, for this go-kart, it is on the top of that hill. And we talked about yesterday that when you're at the top of that hill, you are going to feel a little bit lighter than normal. So the forces acting on this cart are going to be gravity down and normal force up. And because you feel lighter at this location, your normal force will be a little bit smaller. So, if you want to figure out these numbers quantitatively, actually put the numbers in there, you have to use a force equation to do that. Force of gravity is nice and easy because it gives us the mass. The mass is 100 kilograms. So if the go-kart is 100 kilograms, that means the force of gravity is 100 times 9.8, which is 980. So we're halfway done. But in order to actually figure out the normal force, we do have to use force equations. And the bigger force is going to come first. So Fg minus normal force equals ma. And because we're moving in a circle, this is centripetal acceleration. So we want to solve for normal force then. So, to get this by itself, I would think of like moving it over here to make it positive, and then moving this to the left, and then that becomes negative. Everybody on the go-kart? I'll assume that's a yes. So if we want to figure this out then, we actually have all these numbers ready for us. Force of gravity is 980. M times centripetal acceleration, you calculated that in number 4. We got 484. So when we do that subtraction, we're going to end up with 496. And that would be our normal force for the car. So yeah, normal force is this, force of gravity is that. That's how you would answer number 5. Number 6, any questions on 5? Okay. So for number 6, now it says, at what speed would the centripetal force equal the force of gravity? So if you want to figure that out, all you got to do is just do what the question asks. Thanks. And by looking at the question, it pretty much spells it out for us. So we're looking for centripetal force equaling the force of gravity. So we just set force of gravity equal to centripetal force. So force of gravity equals centripetal force. Force of gravity is mg. Centripetal force is mass times centripetal acceleration. And remember, centripetal acceleration is v squared over r. So the equation becomes this. So if you're going to solve for that velocity then, masses go away. Put the r over here. And to get rid of the square, we square root both sides. So when you plug those numbers in, the radius is 25, g of course is 9.8, and you should end up with a velocity equal to 15.7. And that would be your velocity. Any guesses on what this velocity represents? Like, what is the significance of it? In other words, what's the answer to number 6 or number 7? Suppose it's going faster than this speed. What's going to happen to the go-kart when it goes over the hill? Absolutely. The go-kart's going to lift off the ground because your velocity is greater than the force of gravity keeping the cart downwards. So yeah, go faster than that, you're going to catch some air. Let's take a look at the back side. 8, 9, 10, and 11 are the exact same procedure as the first page. Let's take a look at number 12, though. So now we got to do the same thing that we did on the first page, number 5. But in this case, this car is at the bottom of the hill. And if it's at the bottom of a hill, you and the car itself is going to feel heavier than what it normally feels like. In other words, the normal force is going to be bigger under these conditions. So, if I want to figure out what my force of gravity and my normal force are here, I have to do a force equation again, but this force equation is going to be a bit different. Because normal force is bigger, it's going to come first in the force equation. So to solve for normal force, we put force of gravity over to the other side. It becomes positive because it was negative over here, and then we plug those numbers in. We calculated this in number 11, that's 1020. And force of gravity is going to be the same as the previous page, 980. And once added together, we end up with an even 2000. Now my numbers are rounded to 3 digits, so if you did get something a little bit different for these, that's totally fine. But 2000 is a pretty good answer then for your normal force for problem number 12. Questions on 12? All right. Number 13, we probably don't have to go over this one. You follow the exact same procedure here, but in number 12, you're solving for the normal force of the car, and in number 13, you're solving for the normal force of the driver. And if you know the driver weighs 578 newtons, you just have that number in for your force of gravity instead of 980. Thank you very much, ladies. And just have the homework out for me to look at when you get the chance there. Any last questions? Well, okay then. I'll come around and grab this from you.